Today's LeetCode problem. So we have given a parsing a Boolean expression. This is a LeetCode hard problem. So let's see what the question is asking. So we have given a Boolean expression is an expression that evaluates to either true or false. It can be one of the following shapes. T character means true, F character means false. This logical not operations will is a negation, right? So this means that if value is given true, it changes to false, right? I think you know logical not operations, right? And same goes for opposite one. If this is false, it will change it to true, right? So this is given logical not operations, and here we are given AND operation. What does AND operation do? It basically it will take AND operations between all the inner values and return a value, right? So in AND operations, what happens if it is given 0 and 1, it will return 0, right? And if it has 1 and 1, it will return 1, right? So if false is present, it will always return false. If true is present, it will always return true. And if 0 is present, it will return 0, right? You know the basics, right? Same for, we have given OR operations. Same for OR operations, that if there is any value, any true value is present, it will return always return 1. If only 0 is present in case, then it will return 0 in that case, right? Otherwise, if 1 is present in any of the case, it will always return 1, right? These three are the cases which is given, and we have given a true or false character, right? This all is given in characters, right? This is not given in logical and operators, like this is all is given in characters. all is all are given all are given in character form, characters, right? Now, what we need to find, we need to, so we have given a string expression and that represent a Boolean expression. Return the evaluate of the data expression. It is guaranteed that given expression is valid and follow the given rules. So basically, it's we need to evaluate this expression, the string which is given, and after evaluating the string, the answer will be always a Boolean expression, either true or false, and that we need to return it, right? So this is a hard problem only just for implementation. Otherwise, you have, if you have solved problems like valid parenthesis and all, valid parenthesis and all, like these problems, this is very easy problem, right? It's hard, just hard for due to its implementation, right? And if you implement it very carefully, you will be find it's a very easy problem using stack, right? So we have solved this type of problems using stacks in previously also, right? So if you see, if we take any of the examples, let's take this example, right? Let's take this example, and we will find that what with the valid expression, right? So one thing is clear, one thing is to observe here in this case, which is not clear. I don't I In my opinion, it should be clear that how this is the valid form, right? So if for the valid operations, this can't be applicable, right? This f t t, this is not a valid, this is not a valid operation, this is valid, not valid expression. First thing is correct, and we have given valid expression for sure. So this is not a valid operation, so you will not get anything like this. This is the negation operator, and it works only for individual true or false, right? And this is a group. For grouping, for group of for grouping for group, you will always find and or like this, right? Only and or. For negation, it you will only find an individual. This is not valid, right? This is not valid, right? Now, the one thing is to clear that after every logical operations and or and there will be there will be a close and open parenthesis, right? Parenthesis after that, right? So that it is valid. So if you see here, we have after and there is a close parenthesis, after negation there is again a close parenthesis, right? So I am sure about that, that if any of the operations is we need to perform, we need to see this close and open bracket, right? We need to operation, right? So we will just see that how this operations revolve. So first thing is that we move into this, we again move into this. So I got f and t, this is false and this is true. This false and true will group together according to the logical operations which is in before this open bracket, and this is the prefix, this is like and operations, right? So f and t will be, we have like this f and t, logical and operations, and this will give you what, this is false and this is true, which will give us ultimately false, right? So instead of this f and t, we can replace it with false, right? We can replace it with false, right? Now after this we got false, and we also got this close bracket, right? So before this there is a negation value, right? So this negation value will, it will do, it will reverse this, it will it will change this to true, this false will change this to true, right? So this false will change this to true, so answer is true. This is our answer, and if you see, we have got our answer which is true, right? So this is how we solve this question, right? So you need to observe two three things here, before solving this problem, right? So I told you the valid parenthesis cannot be this, like it will always for or and, right? Also for every, so for every logical operations logical operations logical operation, there will be a close and open, there will be a open and close parenthesis, right? That for sure, that for sure, right? So whenever you see and start in parenthesis, you will see that uh, just before the starting parenthesis, open parenthesis, there will be an logical operations between these three, and just before closing parenthesis you need to evaluate before, right? So let's take another example to verify this. So if you have solved valid parenthesis problems, you can easily solve this problem by just thinking that how will you implement it, right? How will you implement it? So I will just suggest you to implement it, try to solve this and implement it first, then show this, right? So then see this video, right? So we will definitely use a stack, definitely use a stack here, right? We will definitely use a stack here, because how can a stack will help us? Because it will help us to move in from the last to first, right? This is LIFO, the stack is LIFO, last in first out. So it will help us to move C from the last value inserted to first value, right? So that's how we will uh, implement it. So we will see the first example at how we will implement it. I have made this example beforehand. So if you see, this is a very good example to mark this solutions, right? So see what will happen, this is negation operator, so we will move inside this, right? Then again, this is a stack one, right? This is a stack one. So this is a negation operator. We will choose this, right? We will choose this. Now again, you will see this is open bracket, right? This is open bracket. It means we need to move further, right? This is again an OR operator, so we can simply see this an OR operator. Insert this OR operator. This is again an open bracket. So this is can move inside this. This is an AND operator, so we can still take this, right? This is again open bracket, so it we can move another part, right? Now you will see this, we have got f, it means this is a false, this is false. It means it means if false and true started to come in characters, it means we are not, we should able to, we're not we don't need to know the all the true and false values between these parentheses, this open parenthesis and the closed parenthesis. So we got f, it means we got a false value, right? So this represent false at a 0, right? So we got this false, right? Again we move further, this is comma operator, right? This is comma operator and this is also character, so we don't need to insert in this, because in stack we only insert those things which matters to us. We only insert those characters which matters to us. And what matters to us, we only matters this logical, or all the logical operators, and true and false, these five things matters to us, right? And what doesn't matter, this doesn't matter, the open brackets, the close brackets, comma, this doesn't means to us. These things only matters to us mainly, right? So we'll insert only these five things here, right? So if you see this f is there, so 0 is present, right? So we will mark this 0 0 here, and also there is a one variables, right? So this is present, right? This is present. Again comma is there, no need to. True is there, right? True is there. So f is there, true is there, so 1 is also there, right? 1 is also there. So f and t is there, right? Now we got the close bracket. Now we got the close bracket. It means now we know that whenever we got close parenthesis, it means we need to evaluate under the expressions which is inside the close balance parenthesis, the close parenthesis, right? So if we got this close bracket, so second thing is when we get a close parenthesis, it means we need to now we need to evaluate the values, the expressions inside inside the parenthesis, right? Then we will move forward because that need to be resolved, right? That's need to be resolved here, right? So we will got a close parenthesis. So for that, what we do, we will first evaluate this. So you remember that why we use a stack here, because we need to move from top to bottom, last in first out. So we will see from last point. See, t is given, it means the true is present, right? So we will mark this one as present, right? When false is present, we can also mark this as present, right? So false is present, true is present, we know these two are present here, right? And till where we move, till this f and t gets evaluated, uh, we will pop this out, right? So t will pop out, f will pop out. Now this and operations, right? This and is a logical operators which will be applicable to this 0 and 1, because you see, for this f and t expression, this and will be evaluated, right? So this and will be applicable to this both of f and t. And what will be the answer if you apply this f and t to and? This is false and this is true, ultimately this will result to false, right? So instead of this there will be an expression called false, right? So this is removed also, and here f will be inserted in place of all these three, right? Now now again we will move forward after this, right? Now if you move forward after this will be marked as 0 again, because we are checking, we need to again mark this for another expressions, right? You will move forward, this comma operator will neglected, this negation operator will again be present here. Again we will move forward because there is open parenthesis, and will be again inserted in stack. Again we will get an open parenthesis, this t will got inserted, t will again got inserted. Now we get a close parenthesis, we got a close parenthesis. Now the same operations, we will pop this t is marked, 1 is present, so we will mark this as 1. F is there, pop this out, mark 0 as present. T is again, we already marked this present, no need to change it. Now we get an and operator. So one thing is to clear, that when we are when we are evaluating the expression inside expression evaluating the expression inside of parenthesis, and we get logical logical operation characters, we will just evaluate and don't move further. We will just evaluate according to that according to that logical operation, and break and don't and stop right there, and right there stop right there for stop there for evaluation. That's what we do, right? So this is and operation again. So this will be now this tft will be applicable to according to this and value. So this and will this removed, and this tft will evaluate on that basis. So this tft is marked as here 1 and 0. So 1 is present, 0 is also present, and this is AND operation. So what will be the answer? 0, right? So this all things will replaced with false, right? And this we also insert this false in my stack, right? Now this close parenthesis evaluation completed. Now again we got a close parenthesis, and that is for this negation part, right? So we again get close parenthesis. Now we will again start seeing from last part. So we get a so this becomes 0 and 0 of now this f is false, we get 0, this is 1. Now this false is out. Negation operators, we got a logical operation, right? We got a logical operation. This logical operation is negation, and we have 0 with our with ourselves, right? So this negation operation will change this 0 to 1, right? So this whole point changes to true, and this negation part is also changes to removed, and this true will inserted in this. Now after moving this, we again got a close parenthesis here, right? We again got a close parenthesis. Now again this will be evaluated. T is present, removed, marked 1. F is present, removed, marked 1. Now we get a logical operations, which is this or. 0 and 1 both is present. Logical or operations will return 1. This will return 1, which is true. This is removed. Again we got a close parenthesis. We have true in ourselves, right? We have true in ourselves, and this will return negation, which is 1 is present, and this is removed, and this is removed. This will return us false, which is inserted in stack. And lastly we will return stack dot top, which is answer is false, which is answer is false, right? And if you see here, in this case, the evaluation, this will give you false, this will give you false, this again, this will give you true, this will give you true, and this will give you false. So, and if you see, the answer is false also, right? So this is how we solve this question, right? So basically what we are doing, we are we are inserting we are inserting these five characters which matters to us, these five characters only in our stack. And whenever we are getting a close parenthesis, we first evaluate the expression and then move forward, right? Forward. This is how we do. Let's see the implementation, you will be better understand. And we are using a stack because it will help us to move from last to first, right? So let's do implementation, you will be better understand. So first thing what we need to, we need to make a stack with a character which will be st, right? Now we will start from 0 to n, we'll move in this expression, right? Okay, what matters to us? These five things only, okay? These five things matters to us, these five things matters to us. And what doesn't matters to us? Comma operators, and what this or sing the parenthesis, right? Doesn't matter to us, right? So we will remove this, we will not insert in, will not insert in stack, right? Now what we'll do, we will start evaluating. The first is expression I. What needs to be inserted, right? What we will insert it. So first thing is that if the character is open parenthesis or the character is comma, we will don't insert it, right? Otherwise, instead of all these three, instead of all these, we will simply insert this, right? We will insert this character. Also we need the checks for this, right? So these three characters don't matter to us, we will not insert it, otherwise we will insert it. And now the main part is for evaluating expression. When we evaluate the expression, when we got this thing, right? So we will check here that whether we have we have characters in my stack or not. If there are characters, then we are evaluating only, right? So what we will check, we have characters means the stack is not empty, and c is close parenthesis, right? Now we can evaluate it. And I told you we need two variables for evaluation, right? Because we don't know, because here we have given false and true as a character, not as values, right? So we need two values. The first is 1, which is marked as 0, and the 0 which is marked as 1. Why I'm doing that? Let's see this, right? Why I'm doing that? Let's see this. There's a logic behind that. So first thing is that if the character elements, let's take st dot top. So and we will just pop this out same with the same top, right? If this element is false, it means we got this 0, we got the 0. So we will mark this as 0, because the false is 0 itself, right? That's why I'm initializing it to 1, and when I'm getting this false, I'm marking it 0, because the false value is 0 in boolean expression. Same goes for element true. When we got true, the 1 will marked as 1, because we have one value as right, real operations as 1, right, not 0. Now when we get this value, which is and odd operators, so this odd operators is telling us that we need to now evaluate the expression which we get either 1 and 0, right? So what we will do, simply we will simply evaluate this expression. And what will the expression? This will be the boolean expression. So I'm not simplifying it. Let's just write like this: 1 or 0. That's the meaning of this operation. That's why I have taken this initializing with 1, and whenever I'm getting the false, I'm marking 0. That's why, because we don't need to change this further, even this here. So when this value is true, if this value is true, it means what we need to return, I'm changing this character to true, otherwise false, right? Now this is seems to be complex, right? This is very it's taking 4 lines. We can simplify this. How we can simplify this? We can write like this: 1 zor 0. If this is 1, what we will do, we will insert true, otherwise we will insert false. This whole thing is same as this, right? This whole thing is this is conditional operator, and this is if else, right? So this whole thing is written as in one line, right? So we will write it like this for each and every one, right? Now for else, if when element is and operator, if element is and operator, we will do the same thing. We just change this to and. Next, else if element is negation, and this negation will just evaluate only on one basis, either 1 is present and 0 is present. We are sure for that, because it will not work for grouping, right? So what we will do, we will check for that if 1 is present. If 1 is present, it means we need to mark it as false, because it is a negation. If 1 is present, it means it will change to false. Otherwise, if 1 is not present, it means 0 will definitely be present, and if 0 is present, it will changes to true, right? So if you seems to be confusing, devise this: if 1 is present, it will mark it as 1, right? So if 1 is present, it will negate it will take a negation and changes to false, so false will insert it. If 1 is not present, 0 is present, it will negation, and true is present, right? That's what it will give, right? Now when and we don't need to move after that, because we got a logical operators. So if you see, I have changed this c values. Whenever I'm getting the logical operations, I'm changing this c. So this will automatically break down this. We don't need to use break or something in this part, right? We don't need to write this break or something. This will simply break it out because this c is already changed. So this value will not, conditions will not satisfy when we change this. So it will simply move to breakdown, right? And now after after changing the c values, it will automatically get inserted because c is either not this, not this, and not this. It is either f or t, right? So this is how we will solve this problem, right? So let's just, and after that last we will just return st.top, which will be either true or false. But this is a character that we need to return false, a boolean value, right? So what we need to do, we will check that if this is true, what we need to do, we will return 1, or you can write true, anything otherwise false, okay? Let's just run this and hope that we have not make any mistakes. Okay, something is missing. Okay, this is missing. Let's just run this again. Okay, let's just run this again, and we have, yeah, bingo. Let's just submit it, right? We have successfully passed all the test cases 100%, right? So this is very easy. You, if you see, you, this is just a valid parenthesis problem. The template is same, right? We are using this same template for valid parentheses, for evaluating all the string operations. So whenever you see evaluating expressions problem, you can think of a stack, right? You can think of a stack. Whenever you get this parentheses, you will start evaluating this purpose, right? So where is the problem? You will face the problem in this part, at how will you evaluate, right? This is how will you evaluate, right? So this condition you can write if else whatever you want, but for simplifying you can write like this, right? So what are the time and the space complexity? The main thing, time complexity. You think, what is the time complexity whenever you start solving for valid parenthesis? O of n, because you see that we are moving in O of n one time, and when we move back, it is all, it is also O of n only one time. So that's would be O of n for this, and the space complexity. So for the stack, it can happen that all the characters get inserted in stack, so that can also be O of n, right? So this is the time and the space complexity for this problem. Hope you understand it. Thank you so much.